Bismillahirrahmanirrahim. Today I'll discuss EPSP and excitatory postsynaptic potential and IPSP and inhibitory postsynaptic potential. Here you can see in this picture there are two neurons. One is excitatory and the other is inhibitory. So when these neurons are excited, so they may cause excitation in the postsynaptic neuron, or they may inhibit, and if they both are equally with the same strength, when the action potential of the excitatory and inhibitory neuron are the same, so there will be no action potential produced in the postsynaptic neuron. So we will discuss this in detail. So what is excitatory postsynaptic potential? An excitatory postsynaptic potential occurs when sodium channel open in response to stimulus. We know that when there is a stimulus to the membrane, so it is depolarized and the sodium actually there is influx of sodium. The electrical gradient drives sodium to rush into the cell. When the sodium brings its positive charge into the cell membrane potential becomes more positive or depolarized. We know that the outside the sodium concentration and also the sodium charge positivity is more than the inside, and when the sodium rush inside, it brings its positive charge inside the cell membrane and cause the negativity of the intracellular fluid into the change into positivity, and this positivity of the intracellular fluid is called depolarization. This change is called depolarization because cell membrane potential is more towards 0 millivolt and the membrane is become less polarized. Here you can see that normally the cell has minus 70 millivolt interiorly. The interior negativity of the cell is minus 70 millivolt, and when the sodium rush, this actually the positivity increase, and this depolarization move towards the 0 level, which is the last point. Beyond this, the cell become activated. So decrease in this negativity towards the positivity, or going towards the 0 level from minus to 0 level, is called a depolarization. At 0 millivolt there is no potential or polarization across the membrane, so the moving towards 0 would be a decrease in the potential. So we know that there is negativity outside and positivity positivity outside and negativity inside, and this negativity is more and positive inside, and positivity is more outside, and this create a potential. So when this the sodium rush, this gradient is decreased, or this potential is decreased. Excitatory postsynaptic potential. This depolarization increase the likelihood a neuron will be able to fire an action potential, which make this ion flow excitatory. When depolarization occurs, this cause this bring the neuron into the action to the action level, and it cause action potential, and this influx of the sodium is then the ion of excitatory ion. These are then become excitatory ion. Therefore an excitatory postsynaptic potential is an excitatory change in the membrane potential of a postsynaptic neuron. A postsynaptic potential, typically brief, and ion channel closing quickly after stimulus occur. If there is not another stimulus, the cell will return to the resting membrane potential. This action, depolarization and repolarization, is a quick process, and if a second stimulation is not occur, so then the membrane become repolarized or come to the resting position. Here you can see that these are the sodium channel, and when the action potential arises, so these channels open and the sodium rush into the interior of the cell and cause the interior negativity of the cell convert into the positivity. Here you can see that the negativity is changed to positivity. Here from -62 towards the positive level. This causes positivity of the inside membrane. Inhibitory postsynaptic potential. An inhibitory postsynaptic potential, or IPSP, on the other hand, is caused by the opening of chloride channel. Remember, in excitation, the sodium channels are open. In inhibition, the chloride channels are open. The equilibrium potential of chloride is -65 millivolt. So if neuron is at rest at -60 millivolt, when chloride channel open, the electrochemical gradient drive chloride to flow into the cell. Here remember that the chloride cause negativity inside, and if more chloride will come inside the cell, it will increase the negativity of the intracellular fluid. Chloride brings its negative charge into the cell, causing the cell membrane potential to become more negative or hyperpolarized. This condition is called hyperpolarized. Here you can see that these are the chloride channel, and already chloride are present, and the cell is in a negative state. When more negative ions enter the cell due to stimulation, it causes further negativity inside the cell. You can see that the negativity is increasing. It is not going in the upward. The potential spike, the graph spike, is not going in the upshoot, but it is now going down, and the cell has become more negative. So this is called hyperpolarization. So inhibitory postsynaptic potential, this change is called hyperpolarization. When there is more negativity inside the intracellular fluid, this more negativity or increased negativity is called hyperpolarization, because the cell membrane potential is moving away from 0 millivolt, and the membrane is become more polarized. Here is the 0, and this is -70, and it is further, the negativity is further increasing. So this is become more polarized. And inhibitory postsynaptic potential decrease the likelihood a neuron will be able to fire an action potential, which made this ion flow inhibitory. So the influx of negative ion to the interior of the cell actually cause inhibition of the neuron, and these ionic flow from the outside to the inside is called inhibitory ion flow. Therefore, an IPSP is an inhibitory change in the membrane potential of a postsynaptic neuron. When negativity is increased, the neuron is inhibited and no action potential is produced in the postsynaptic neuron. The same is here, that this inhibition is for typically brief, and the membrane potential will return to the resting if not additional stimulus occurs. If the neuron is not further inhibited, so the cell will become repolarize or come to the resting state. Now simultaneous summation of inhibitory and excitatory postsynaptic potential. Here you can see there's two neurons. One is, as I discussed it in the previous slide, there are two neurons. One is excitatory and the other is inhibitory. If the excitatory neuron produce the postsynaptic, excitatory neuron produce a depolarization of the postsynaptic neuron, and at the same time the postsynaptic neuron cause inhibition of the postsynaptic neuron. This will cause no change if both are of the same strength. The excitatory and inhibitory chain are both of the same strength, so it will cause no change in the postsynaptic potential of the neuron, and this is completely or partially nullify each other. They actually, the excitatory and inhibitory neuron actually nullify, or they block each other, and they don't allow any potential to the postsynaptic neuron. Thus, if a neuron is being excited by an excitatory postsynaptic potential and inhibitory signals from another source can often reduce the postsynaptic potential to less than threshold value for excitation, thus turning off the activity of the neuron. So in this condition, neuron will remain white and there will be no activity in the postsynaptic neuron if both the excitatory and inhibitory neuron have the same activity or the same strength of excitation. Facilitation. Postsynaptic potential is excitatory but has not risen high enough to reach the threshold of firing by the postsynaptic neuron. If a neuron is activated, suppose here 4 neurons activate and they create 4 neurons are activated and 4 synapses are firing, but this firing is not sufficient to create action potential, but in this condition it causes facilitation of the neuron. And other stimulus, here you can see that if 8 neurons are stimulated, this further facilitates the neuron, and when 16 neurons are excited, 16 synapses are stimulated, and this facilitation actually causes bring the neuron to the point where the neuron can then produce action potential. So this summation of the presynaptic neuron excitation, when it causes the postsynaptic excitation of excitatory potential, is called facilitation. Diffuse signal in the nervous system often do facilitate large group of neurons so that they can respond quickly and easily to signal arriving from other sources. So multiple neurons can stimulate a single neuron that can cause postsynaptic, first facilitation and then action potential. Excitatory neurotransmitter. Glutamate is the main excitatory neurotransmitter. The glutamate binds to its receptor on the postsynaptic membrane. This binding causes a sodium cation influx. When glutamate attached to its receptor, it causes opening of the sodium channel and causes influx of the sodium into the interior of the cell or into the intracellular fluid and cause depolarization. This is called an excitatory postsynaptic potential. It is essential to note that for the excitatory postsynaptic potential, summation to reach the threshold potential, a large number of these inputs are required. So we need a large number of this input. This input means that the large number of glutamate may be released. The difference between excitatory postsynaptic potential and action potential is that excitatory potential, postsynaptic potential are able to summate their input, producing a graded response as opposed to the all or nothing response in which the threshold potential may be reached, stimulating an action potential, or it may not be reached at all. So, in summation, if the summation is sufficient, action potential will produce. If the summation is less, there will be excitation of the neuron, but there will be no postsynaptic action potential. So this is actually the situation in which if the stimulation or neurotransmitter are released in less quantity, this will lead to the decrease stimulation of nerve, and it will not cause postsynaptic action potential. Inhibitory neurotransmitter GABA is the main neurotransmitter involved in inhibitory postsynaptic potential. On binding to postsynaptic neuron channel allow an influx of negative charge anion or efflux of positively charged cations. So in this condition, as we have discussed in the action potential, when the negative charge ion enter the cell, the positive charge ion leave the cell. At that time, the positive ion like potassium leave the cell. The action in this case is chloride. The anion in this case is chloride. The negative ion in this case is chloride. The efflux cation are potassium ion. So the negatively charged ion are chloride, and the ion which leave or efflux from the cell is the potassium. Both ions have the same effect in lowering membrane potential, causing hyperpolarization of the postsynaptic neuron. The summation of these IPSP and the drop in number voltage will deviate away from the threshold potential, inhibiting an action potential. So this influx of the negative charge neuron to the inside of the cell will inhibit the action potential in the postsynaptic neuron. However, the inhibitory postsynaptic potentials and excitatory postsynaptic potential may be occurring at the same time. Hence, the postsynaptic neuron may be receiving excitatory signal from the glutamate and inhibitory signal from the GABA. The goal of inhibitory glutamate is to lower membrane potential away from the threshold potential by hyperpolarization. So thank you. This was all about the excitatory and inhibitory postsynaptic potential. Thank you. Please subscribe the channel and press the bell icon. See you in the next lecture. Thank you once again.